Hello everyone. Today I will talk about the HPC on AWS, an article called The Cost of a Cloud Research Problems in Data Center Networks said two choices. One way is creating more than 100,000 computers to be faster. Another way is creating a small data center for users, but it could be expensive. What AWS will do? How to do big job and small job at the same time? This presentation will tell you. For the first part, I will use an example to show the difference between local HPC clusters and HPC on AWS cloud. Because the features of my topic, it is hard for me to analyze the parallelization of matrix multiply, but I find another example that could be helpful to understand the parallel programming. That is MPI program, message passing interface. It is the most important model of HPC. What is MPI? All it means is that an application passes messages among proxies in order to perform a task. This model works out quite well in practice for parallel applications. For example, a manager process might assign work to worker process by passing them a message that describes the work. We need to know that MPI is only a definition for an interface. We just create implementations of the interface for our respective architectures. So there are multiple ways to use MPI. The first is MPI in local. The first example is to run the project with normal way. I can run the program on MPCH 3.2.1 version. That's okay for me. The example I choose is the most popular one, the Hello World example. That's the source code of the program. You can see that the first step is include the file named mpi.h. Then we can initialize the environmental. It can create all the variables we need, such as communicator. Each process can have a unique rank. I will use a makefile to compile this program, then use Python script to run the code. As we want, the MPI program run on each node I provide. If the node are machine with more than one cron, I can run this MPI program on each cron by changing the host file. The second part is MPI in AWS platform. AWS provides most things we want. All we need to do is just follow its guide. To research HPC on AWS, the EC2 instance is necessary. For this presentation, we just choose the free version. If you want to start a cluster with more than 2 nodes, just change the cluster size option. It may need some money. Now I will run a simple MPI job with the AWS keyword called AWS batch as the schedule. This is AWS style. Let's find the difference. The first step is install AWS parallel cluster and configure the CLI. Just follow the guide provided by AWS document. Although the AWS parallel cluster batch CLI commands are all available on the client machine where parallel caster is installed. We are going to SSH into the master node and submit the jobs from there. So that we can take advantage of the NFS server that is shared between the master and all Docker instances that run batch jobs. Log into the master instance first. Use the pcaster keyword. Then run the commands keyword and AWS host to show the configured AWS batch cron and the running EC2 instance. As you can see from the screenshot, AWS provides everything for you, such as host file or configuration. Compare with the local MPI program. AWS provides you a user-friendly interface with lots of functions. As we did on the example above, create a file called helloworld.sh. That is the code here. It's the cron and status of the job. There are a lot of AWS keywords you can use to help you do this MPI job. Here are the screenshots. We can see that the MPI job successfully run on the instance now, and you can check everything and the configurations during the command line. Also, I will talk about how to run MPI job in a multiple node parallel environmental. The example file I use is mpi helloworld.c, just like the example we said before. You will find it's very similar than the last example. Now, save and submit the code with keyword submit mpi.sh, then make it run on 3 nodes. The job is running now. We can check its output of the main node from this screenshot. The MPI job is running successfully. As we can see, AWS provides a lot of keyword and functions that help users run the project. Compare with the local MPI job. HPC on AWS doesn't have to make it all by user himself. AWS helps them monitor the process. HPC on AWS removes the long wait times and lost productivity often associated with local HPC cluster. Flexible configuration and virtually unlimited scalability allow users to grow and strengthen their infrastructure as their workload dictate. Another benefit is flexible configuration. All the configurations can move to AWS Cloud. The developers can run their job on any available configuration. The left side is its features. You can see all the configurations are provided by AWS. Users can check and change a little. The right side is the MPI caster within a line. All the configuration files are created by users. They also need to install extra tools such as MPI ch2. This is third part. HPC on AWS is one part of HPC, but it has more advantages. For example, it is much more stronger. Or we can say popular from this screenshot. It has a lot of nodes and regions. It also supports all kinds of HPC applications and servers you can find on the world. Price are very important for every user. From 2016-13 to now, AWS keeps reduce its fees and provide more free serve. Users only need to pay for the capability they use. For myself, I can see that there are more and more big companies and organizations choose HPC on AWS to start their business. Even for my future IT career, I need to learn how to use it, which means this is very important for me.